We're going to be talking about rate of change. Another name for rate of change is slope. So we're going to be calculating what we've been calculating before, but instead, as we look at word problems, we are going to have to determine the ordered pairs. In order to determine the ordered pairs, we need to know what number is going to go in the x spot and what number is going to go in the y spot. And that is going to be determined by the following. Is a variable dependent or is a variable independent? If the variable is independent or it's an input, it is going to be the x part of my coordinate. Independent variables stand on their own. They don't rely on anything else to happen in order to make them happen. Time is an excellent example of this. For example, if I'm counting what year it is or how many years have passed, nothing is affecting how much time has passed. It continues to pass on its own. Same with hours and seconds. Other types of independent variables include items that I'm going to buy. That is something that is chosen by the experimenter, and it stands on its own. That how much you're going to buy affects the cost, and that would be the cost would be dependent. The dependent variable is the output or the y variable. It depends or is affected by the independent variable. So the cost is affected by how many packages of Oreos I choose to buy. Now, how do I calculate this rate of change? Just as a reminder, here's my rate of change formula. y2 minus y1 over x2 minus x1. The top represents the change in the dependent variable, and the denominator stands for the change in the independent variable. So let's look at an example. In 2012, Katie has 400 Instagram followers. In 2015, she has 1,300 followers. Find the rate of change. The first thing that you need to do is identify and figure out what is the independent variable and what is the dependent variable. As I look at the numbers that are listed and their units, I can make that determination. 2012 is a year. 400 represents the number of Instagram followers. If I use the following sentence, or try to construct the following sentence, I can determine which is my independent variable. Is the number of Instagram followers going to depend on what year it is? Or does the year, what year it happens to be, is that determined by how many Instagram followers I have? Or does it depend on the number of Instagram followers I have? And the answer is that the followers depend on the year. As the years go on, I have a different amount of followers. Okay, but the number of followers does not affect how many years have passed. So my input is my year, and also remember this is time. So it is what I would expect to be my independent variable, and my output or my dependent variable is my followers. So let's go ahead and write our ordered pair. And this is something that I would like you to write down each time. So what is the year 2012? What is the corresponding number of followers? 400. In 2015, what's the corresponding number of followers? 1,300. And now let's use our slope formula to calculate. So just as a recall, there's my slope formula. Here's x, here's y. That's my first point. Here's x, here's y, here's my second point. So y2 minus y1 divided by x2 minus x1. I'm going to simplify 900 over 3, continue to simplify 300, and the last thing I need to do is put my units. And when you write your units, you always write them in y per x. What do I mean? Start with the y variable. Followers per your variable. All right, let's calculate another. The group cost of a trip to the museum for 4 people is $48, and that's a typo, whoops, and $78 for 10 people. Find the rate of change. Now, some people might be just tempted to divide. 48 divided by 4 is 12, done, $12 per person. But if you look at your other money value and the number of people that are allowed to come in, 78 divided by 10 is not 12, it's less. So there had to be some sort of initial cost for my group and then a cost per person. So we are in attempts to find that rate of change or cost per person. So let's go ahead and define our x and our y, our independent, which is x, and our dependent, which is y. So again, I can write my depends statement. Let's look at what our variables are. So we have 4 people. So people is one of our units, and $48. So dollars is one of our units. Again, commonly, if you're buying something, the money is my dependent variable, and it depends, the money depends on how many people come. So, okay, number of people is my x variable, and my y variable is the dollars that I spend. Let's go ahead and write our ordered pairs. If x is represented by the number of people, then first spot is I'm going to put number of people, which is 4, and the corresponding number, which is 48. My second point, now a lot of people might just write 78, 10, because that's the order that it comes in the sentence. Be aware that I need to make sure that I put the number of people in the x spot. So 10 and then 78. And let's calculate. Here's my fraction. y2 minus y1, x2 minus x1. Simplify. 30 over 6 equals 5. So what's my answer? 5. And remember to go to your units. Dollars per number of people, so per person. And that is my answer. All right. Last example. A scuba diver is 30 feet below the surface of the water after 10 seconds. After he entered the water. And 100 feet below the surface after 40 seconds. What is the scuba diver's rate of change? So first, let's determine our units. So what depends on what? I'm going to notice so I've got 30 feet below as one unit, and 10 seconds as seconds is my other unit. So feet and seconds. And now I need to decide, does the feet below depend on how many seconds have passed, or the other way around? Well, remember, time is always, in this case, my independent variable. So I'm automatically going to make seconds my input, because the feet I am below the surface depends on how many seconds I've been diving. And y, my units, is going to be feet. All right, so let's go ahead and calculate this. We need to write our ordered pairs first. If seconds is my input, okay, 10 seconds, 30 feet, those are tied together. So 10 seconds and 30 feet below. So instead of writing 30 feet below, I am just going to write negative 30, indicating that it's going down. Our second value, we've got 100 feet below and 40 seconds tied together. So make sure 40 comes first because it is seconds, and negative 100 comes second. All right, now let's calculate. Negative 100 minus a negative 30 over 40 minus 10. Well, minus a negative is adding. So negative 70 over 30. Now that's not simplified, so let's simplify it. Negative 7 over 3. Now how do I put units on it? Negative 7 over 3 feet per second. And if you want to, you can actually make a different interpretation by splitting up the numerator and the denominator. And negative 7 would go with feet and 3 would go with seconds. So I would say down 7 feet per 3 seconds. And either interpretation would be correct. All right, if you have any questions, please reach out and have a great day.